All right, guys, we are going to take some notes now on section 5.3, which is graphing cubic functions. So this is the first time you've graphed any cubic functions in any class. Cubic function is anything of the form x cubed, meaning its highest exponent power in the equation is cubed. You've done quadratic equations in integrated 2. Quadratic equations are ones with squares in them. Those are parabolas. And we'll do a little bit with that together in class when I see you, just to kind of give you a little bit of review of graphing parabolas. Now, cubic functions, standard form here is where you have an ax cubed plus bx squared plus cx plus d. Honestly, that's not something you're going to need much of right now. The parent function is y equals x cubed. So the parent function is the one that all the other functions are formed from. So one of the things you're going to hear me say a lot whenever we do the graphing in this class is when you don't know what the picture looks like, you got to start with a table, and you want to start with the most basic of the functions. That would be the parent function, y equals x cubed. And we'll actually plug in a few values now into a table, and then we'll plot these over here on the graph. So usually when I have no idea what anything looks like, I start with these values, -2, -1, 0, 1, 2, sorry, we don't need 3, just -2, -1, 0, 1, and 2. And all you're going to do is you're going to plug those in. So you're going to do -2 cubed, which means -2 times -2 times -2, that's -8. -1 cubed, that's -1 times -1 times -1, that is -1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. Now what you want to do is plot those points, and we'll try to get a look at what this appears to be. So -2 down to -8, -1, -1, 0, 0, 1, 1, and 2, 8. There is what my parent graph looks like. Now, in order to help you kind of graph this and see kind of what it looks like, this is the way I would think of it if I were graphing for you. From this middle point here, you'll notice there's really kind of like half a parabola that goes up. Now, it's not half of a parabola, but it looks that way, and it's okay to think of that for making your sketch. And then half a parabola that goes down. And there is what the equation y equals x cubed is going to look like. Now, that is the parent function. And when we get together in class, I'm going to give you more detail about this. But right now, you're just kind of getting a little bit of a basic look at it together. Now, what I want you to focus on is this middle section here. What is a rule? And that's what we're going to look at for a lot of the equations in this class. What is the rule in order to graphing that? So from this middle point here is where I'm going to start. So I'm going to circle that one. How do you get from this point to the next point is what I want you to think about. How do I go from this middle point to the next point? Well, if I were giving you directions from this house to this house, I would say go up a street, over a street. So I'm going to say up 1, over 1. And from that middle point, how do I get to this house? I go down 1, back 1. So down 1, back 1. Now, with that rule, that parent graph, what we're going to be able to do is we're going to be able to do all the stretching, compressing, moving right, left, up, down that we need to do just from that rule. Okay, so you're going to get a lot of practice with this. You're going to get a little bit of practice now so that you've got some basic understanding when we come together in class, whatever day I have you for this, either Thursday or Friday. So let's jump right into this. So this is what I was talking about here, that you're using these points. You're going to transform them. You don't really need to memorize this. You just need to know the rule. Okay, so let's write that down one more time, that the rule is up 1, over 1, down 1, back 1. This is for a y equals x cubed. So any cubic function, we're going to use this method, especially if we're in the form that we need here. Okay, so first thing we've got to do is we've got to refer back to our whole ABHK thing. And so what we're going to do is we're going to look at this equation in terms of this is our A, this is our H, this is our K. So we got a lot of work to do on this because I know for some of you you're going, whoa, 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 where'd that come from? Well, the idea is that if you had a general form of a cubic function, it would look something like this. Let's write it at the top of our paper. The general form would look like this. Y equals A, parenthesis, 1 over B, parenthesis, X minus H, parenthesis cubed, minus 1. Or sorry, minus K, not minus 1. That problem that we just did has a minus 1. Sorry. So it would look something like this. So we saw this in the first lesson, this A, B, H, K idea, and how to transform using that. Remember, A was a vertical stretch or compression and a reflection across the X. 1 over B was a horizontal stretch or compression and a reflection over the Y. The H is a right-left. The K is an up-down. Okay? So here's what I'm going to do with this. Okay? Get your best mindset on this so that you have a chance to understand, especially when we get together. Okay, so if your A is 2, A is our vertical stretch, what we're going to do is we're going to say this is a vertical stretch factor of 2. Okay. Now a minus 1 inside, that's an H. Remember, it goes opposite of the way you're thinking if it's inside the parentheses. So we are going to go right 1. And then for our K, being minus 1, we're going to go down 1. Okay. Now, I'm a parent. I can tend to be a little bit on the boring side, probably in my kids' eyes. So where do the parents always start from? The most boring part of the graph would be from 0, 0. So what we're going to do is we're going to move 0, 0 according to the right one, down 1, and then we're going to vertically stretch our rule by a factor of 2. Now again, you got to have your mindset on what we're doing, otherwise you don't have much of a chance on this. Okay, so again, get your mind on what we're doing. So what I'm saying is I'm going to do this first, and then I'm going to do this second according to the rule. So here's what I'm saying. Off of 0, 0, we're going to go right 1, down 1. Again, we're going to practice this together in class, but if you've watched this and taken the notes now, you have a chance of understanding what I'm doing whenever we do this together in class. So again, I moved off of 0, 0, right 1, down 1. Okay. And now what we're going to do is we're going to vertically stretch our rule by a factor of 2. Now, up, down is my vertical part of this. If you're going up, you're going down, that's vertical. Okay, so up, down, vertical. So what I'm going to do is I'm going to change this up, down by a factor of 2, meaning multiply it by 2. So instead of going up 1, we're going to go up 2, but we're going to keep the over 1. We're going to go down 2, and then go back 1. So we're not changing the overs and backs, we're changing the ups and downs by a factor of 2. So what you're going to do is from this point now, you're going to go up 2 over 1, go down 2, back 1. Half a parabola up, half a parabola down, and you just graphed that equation. Okay, now, do you get it at this point? No. Okay, so let's get another one here. Let's go to letter C, because the next two, they have some horizontal stretches and compressions. That always is a little more complicated. All right, so first thing you want to do is you want to think about the rule. Let's write down the rule. Okay, now what is the rule? We're using the one for x cubes because it's a cubic function. So the rule for y equals x cubed is to go up 1 over 1. This is standard. And then go down 1, back 1. Now we may end up changing this based on the information here. So based on the first lesson, a negative in front is going to reflect across the x-axis. Again, that's the work here from the first section. The 3 is going to give us a vertical stretch, factor of 3. The plus 1 is going to move our starting point. It's going to move us left 1, and then the plus 2 is going to move us up 2. Okay, so again, you're going to do this part first, and then you're going to do this stuff together second. Okay, you need to have a starting place, and this gives you a starting place, and then you can stretch the graph. Okay, again, we're going to get better at this in class, but we got to get a start on it now. Okay, so let's go left 1. So from 0, 0, from the middle, we're going to go left 1, and then we're going to go up 2. So left 1, up 2, you should be at the point -1, 2. All right? Now, according to the rule is to vertically stretch by a factor of 3. Vertical is the up-down. So we're going to change the up-downs to 3. Now, to reflect means to flip something over. We are reflecting across the x. The way you're going to do that is with these values. Okay, you're not going to change the over back because this is all vertical. So what you're going to do is you're going to change an up to a down. That's how you would reflect. You would change it from what it was. And you're going to change a down to an up. Okay, so here's what you're going to do. You're going to go down 3 over 1. You're going to go up 3. This is from your middle point always. Up 3, back 1. Okay, over is to the right, back is to the left. And now you'll connect those, half a parabola this way, half a parabola that way, and there is your cubic function. All right? Okay, I've got to pause there. I'm going to give you a little bit of a break, and then I want to come back and I want to do the ones that have the horizontal stretch or compression here together, and then you'll have some notes on this section. All right, so take a little break, and then we'll come back and do these next two.